Hi student, this video is about integration of rational function. If we have rational function, it can be proper or improper. So to apply integration of rational function, we will use partial fraction decomposition (PFD). Okay, before we apply PFD, our rational function needs to be proper, and then we can solve. But if we have improper rational function, we need to apply long division, and then we can apply PFD and solve. Okay, how to identify our function is proper or improper? Okay, for example, if we have a rational function in form of mx equal to px over qx. Px refer to numerator, function at numerator, and qx is function at denominator. So if degree of px less than qx, so we call the rational function as proper rational function. Okay, for example, if we have example 1, x over x square plus x. So the degree of px, degree mean the highest power of x. So here at numerator we have highest power of x equal to 1. So the degree of px equal to 1. And then denominator we have x square plus x. So the degree of qx is equal to 2. Since the degree of px less than qx, so we call this as a proper rational function. And then example number 2, if we have 3x plus 1 over x square minus x minus 6, so the degree at numerator equal to 1. We have 3x plus 1, so the highest power of x is equal to 1. And then denominator we have x square minus x minus 6, so the degree of qx is equal to 2. So since px less than qx, so we call this function as proper rational function. And then for improper rational function, if degree of px greater or equal to qx, so we call that rational function as improper. So based on example 1, we have x square plus 3 divided by x square plus 5. So the degree at numerator or px is equal to 2, and then the degree of qx at denominator equal to 2. Means we have px equal to qx. So this is improper rational function. And example number 2, we have 4x cubed minus x divided by x times x square plus 5. So the degree of px equal to 3, and then the degree of qx equal to 3. Mean px equal to qx. So this is improper rational function. So for this video, I will show you how to solve proper rational function. Okay, when we have partial fraction decomposition (PFD), okay, we have based on this table, how to write in form of PFD. First, we need to know the factor for qx. Qx mean function at denominator, and then type of factor. Okay, for example, for factor number 1, we have ax plus b mean non-repeated linear. So to write in form of PFD, we write as a over ax plus b. Or for example, we have x plus 1 times x minus 1. Okay, function in bracket is linear function and non-repeated. So to write in PFD, we can write as a over x plus 1 for the first bracket, and then plus b over second bracket x minus 1. Okay, next example number 2. If we have x minus 3 times 2x plus 1, so both function in bracket is linear, non-repeated linear. So to write in PFD, for the first bracket, we can write as a over x minus 3 plus second bracket b over 2x plus 1. Okay, next, if we have repeated linear, we have in form of ax plus b power m. So you can write as a1 over ax plus b plus a2 over ax plus b square plus plus a power am over ax plus b power m. So we can end at based on power. So for the first example, if we have x plus 1 square equal to x plus 1 times x plus 1, and then you can write as a over, for the first bracket, x plus 1 plus, we have two terms, plus b over, and then we have power square, so x plus 1 square. Move to example number 2. If we have x plus 2 cube, mean we have 3 bracket here. So for the first term, you just write a over x plus 2 and then plus b over x plus 2 square plus c over x plus 2 cube. And lastly, we have quadratic in form of ax square plus bx plus c. So if we have quadratic, for example, we have x square plus 1, so you can write as ax plus b over x square plus 1. Okay, next we move to first example. Okay, given that x square plus x plus 1 over x cube plus 2x square equal to a over x plus b over x square plus c over x plus 2. Okay, 1 Roman, find the values of a, b and c by PFD, and then 2 Roman, solve, integrate x square plus x plus 1 divided by x cube plus 2x square dx. Okay, for the first step, we want to find the value of a, b and c based on PFD. So first step, to answer this equation number 1 Roman, okay, to find the value of a, b and c, or to write this function in form of PFD, actually we need to factorize the denominator. So we have denominator equal to x cube plus 2x square, and then if we factorize equal to, we can factor out x square, so get x square times x plus 2. Okay, since we have x square is not quadratic, x square is quadratic, but we can factor, so equal to x times x plus 2. So here we have repeated linear and linear, non-repeated linear. So we have two types. Okay, next, we can write as x square, our equation, plus x plus 1 over x cube plus 2x equal to, okay, we have the first factor, we have repeated linear, this one non-repeated. Okay, for repeated linear, we can write in PFD in form of a over x plus b over x square. And then for non-repeated linear, you can write as plus C over X plus 2. Okay, and then how to find this value? Actually, we can compare coefficient. So to compare coefficient, the denominator at left hand side must be equal to right hand side. So we can perform cross multiplication. So equal to A times x square times x plus 2 plus B times x plus 2 plus C times x square, and then divide by x times x square times x plus 2. Okay, if we expand denominator on right hand side, actually it not equal to x cube plus 2x square. So we can factor out this x. So equal to numerator, we can factor out x. So we get x times A times x plus 2 plus B times x plus 2 times C x square divide by x times x square times x plus 2, and then we can cancel out this x. So if we expand denominator, we get equal to left hand side. So you can expand both numerator and denominator. So equal to A x square plus two AX plus BX plus 2B plus CX square divide by, okay, denominator we have x cube plus 2x square, and then we can group this term. So x square we have A plus C x square, and then x plus 2A plus BX plus 2B. 2B here refer to constant. So actually left hand side we have x square plus x plus 1 over x cube plus 2x square. Okay, this one over x square plus 2x square, and then we can compare coefficient. Okay, for the first coefficient of x square, we have A plus C. So A plus C equal to coefficient of x square on left hand side equal to 1. So this is first equation. Okay, for coefficient number 2, we have 2A plus B for x. So 2A plus B equal to, okay, coefficient for x on left hand side we have 1, and then lastly we have 2b constant. So 2b equal to left hand side constant equal to 1, or b equal to 1 over 2. And then to find the value of A and C, we can substitute the value of 1 over 2 into equation number 1 and 2. So we have 2A equal to 1 minus B equal to 1 minus 1 over 2 equal to 2 minus 1 over 2 equal to 1 over 2. But A equal to 1 over 4. And then C equal to 1 minus A, equal to 1 minus 1 over 4 equal to 3 over 4. So we can write our function as so our function can write as x square plus x plus 1 over x cube plus 2x square equal to, so we have value of A equal to 1 over 4, so 1 over 4 over x, plus B we have 1 over 2, so 1 over 2 over x square, plus, and C we have 3 over 4 over x plus 2. So this is answer for 1 Roman. And for 2 Roman, we want to find integration of this function. So to integrate this function, actually based on PFD that we have performed. So integrate x square plus x plus 1 over, this is 2 Roman, equal to x cube plus 2x square dx equal to, integrate 1 over 4 over x dx plus integrate 1 over 2 over x square dx plus integrate 3 over 4 over x plus 2 dx. And then we can integrate 1 by 1 or term by term. For the first term, we have constant 1 over 4. So we get 1 over 4 ln x. Why the answer is equal to ln? Because function at denominator is linear. For the second term, it can be ln because function at denominator is quadratic. So we can write as plus integrate, or we can write as 1 over 2 integrate x power of negative 2 dx. We can simplify first and then plus, on third term we have linear on denominator, so we get 3 over 4 ln x plus 2 plus c. And then equal to 1 over 4 ln x, plus 1 over 2, and then integrate x power negative 2 equal to x power negative 1 divided by negative 1 plus 3 over 4 ln x plus 2 plus c. Or we can write the final answer equal to 1 over 4 ln x, minus 1 over 2 x plus 3 over 4 ln x plus 2 plus c. So this is the final answer. Okay, next one more example. Given that negative 5x plus 2 over x plus 1 square equal to a over x plus 1 plus b over x plus 1 square. Okay, for 1 Roman, find the values of a and b by partial fraction, so PFD. And 2 Roman, and solve integration of negative 5x plus 2 over x plus 1 square dx. So for the first solution, for 1 Roman, okay, to write in form of this partial fraction, we need to factorize denominator. So since based on question, this denominator is in form of factorization, we have x plus 1 square, so we can write as x plus 1 times x plus 1 square, or a over x plus 1 plus b over x plus 1 square. So we can compare coefficient for 1 Roman. So negative 5x plus 2 divided by x plus 1 square equal to a over x plus 1 plus b over x plus 1 square. And then to compare coefficient, the denominator at right hand side must be equal to left hand side. So we need to perform cross multiplication. So for the first term, we can multiply with x plus 1. So a times x plus 1 plus b over x plus 1 square. So the denominator at right hand side equal to left hand side, and then we can expand numerator. So we get x plus a plus b over x plus 1 square. So for coefficient of x, we have a on right hand side, so we have a equal to left hand side negative 5. So this is first equation, and then we have b constant, so we have a plus b equal to 2, or b equal to 2 minus a equal to 2 minus negative 5 equal to 7. So we can write our rational function negative 5x plus 2 over x plus 1 square equal to, okay, a we have negative 5, so negative 5 over x plus 1 plus b equal to 7 over x plus 1 square. So this is the final answer for 1 Roman. For 2 Roman, we need to solve this function. So for 2 Roman, so integrate negative 5x plus 2 over x plus 1 square dx equal to integrate negative 5 over x plus 1 dx plus integrate 7 over x plus 1 square dx. And then we can integrate term by term. For the first term, since denominator is linear, so we get negative 5 ln x plus 1. Okay, for the second term, since a denominator is quadratic, so we can let as u. So let's u equal to x plus 1 du equal to dx. Okay, plus integrate 7 over u square time du, we can simplify this, equal to negative 5 ln x plus 1 plus integrate 7u power negative 2 du, and then we can integrate to negative 5 ln x plus 1. Okay, and then integrate this term. Okay, plus 7u. Okay, integrate u power negative 2 equal to u power of negative 1 over negative 1 plus c. We can write as equal to negative 5 ln x plus 1 minus 7 over u plus c, and then substitute u, so equal to negative 5 ln x plus 1 minus 7 over x plus 1 plus c. So this is the final answer. Okay, thank you.